Get what you want.
Boom, we're live. All right, there we go.
Yeah, we'll talk after.
We'll
talk after.
That was a good half hour of our life, right? Okay, so we've done RO and DI. Got your heads around that. Did any questions come up? Close that off, right? So now we want to talk about water pit pole safety and efficiency. So could you grab the brush and the pole, all the little things that I'm going to need just out of there. So, how many of you are boss and how many of you work, or who works for somebody else among you? Right, okay. So some of this is actually more powerful for you as the working person who's not the business owner than it is for the business person, because if you get it, then you're the person from safety and efficiency point of view, you're the person who can put it into action. A boss can lead you to it, but he can't make you do it. So what the most important thing is to understand what we're talking about is actually work. So just that little pole, let's try it. I'm just going to take this. That, yeah, good that, yeah. Good to go. And the brush, I need the brush. Please. And then I'm good. Yeah, those and prisms. So, okay. That's it. Bada bing, bada boom. I'm ready. Okay, so the topic actually is work, because this presentation is about safety and efficiency. So the actual topic is about work. So in order to, somebody said to me when I put a little picture of this up on Facebook, he said, what do you think you do? You sell water pit poles, or do you think you're a science teacher? Right? And I think, maybe I'm a science teacher right now. Okay, so there's going to be three little science lessons that I'm going to go through, because if it makes sense to you, right, then you're going to be able to put it into place. If I just tell you, you can go 5 times faster with a Reach-it, it's not, like it's just he said it, I don't know, blah, blah, blah. So I'll show you from a physics point of view and an educational point of view. And then from there, you get the chance to put it into action. So what is work? If you go to wikipedia.com, screaming women in the background, right? So if you go to wikipedia.com, you'll find out that the definition of the word work is actually in physics. That work is a physics term, and it's called force through distance. Yeah, force through distance, and it's measured in calories. Now, this training is not very interactive, but a little bit interactive. So here's your first question. What else is measured in calories?
Food.
Yes. Boom. So food is measured in calories. So this is how it looks. We work, we eat, we work, we eat, we work, we eat, we work, we eat. We go to the gym, is working, we eat. We rest, we're not working, we eat, we work, we eat. Calories in, calories out, calories in, calories out. Put more calories in than you consume and you'll get fat. Put less calories in than you consume and you'll get skinny. Right? That's as simple as it is. Right? A balance of working and eating. So, in order to understand that this force through distance, we should understand what is force and what is distance. Yeah? Like just to make sure we're all on the same thing. So force is the effort applied to acceleration and continued movement. So if I said to you, imagine this, that you get in your car and I say, hey, drive to the end of the street and back. So you get in your car, wow, I'm really tall, that's too close to my head. So you get in your car and you put the foot on the accelerator, so you're basically applying effort from the motor, right? And then you accelerate. Now if you continue to accelerate to the end of the street, something's going to go wrong at the end of the street. So you choose your comfortable speed, and then you have continued movement. But you'll notice that you don't take, unless you're going downhill of course, but you don't take your foot off the accelerator to maintain speed, right? You keep your foot on the accelerator. So you have continued movement requires force. And then you get to the end of the street, towards the end of the street you're going to decelerate, and at the end of the street you're going to stop. Then I'll say, okay, put it in reverse, accelerate until you get to a comfortable speed, maintain your comfortable speed, and then decelerate and stop. Right? So that's the use of force. Now just so you get it, if this was my squeegee, right, and I wanted to put the squeegee on the glass, it starts stationary, and then I need to, oh, maybe I'll come in here. If I need to move the squeegee, I need to accelerate it, and then continued movement, right? So you know, why am I saying this? Is because this applies to everything you do. Even with a pressure washer, you know, even if it's a wand, it starts stationary and then you move it. That's the acceleration, right? And then you maintain its movement, or a surface cleaner, or whatever it is. So everything that you do with work is basically acceleration and continued movement, and then deceleration and stop, you know, in order to go around the circle. So distance is the full distance, the full range of movement required to affect the task. So it's the distance, it's not the distance to the end of the street, it's the distance to the end of the street and back, right? Is the distance that we traveled in that little imaginary exercise. So here's the thing, what we do is that we work in cycles. So by getting you to visualize this, you know, doing something and then coming back to a starting point is to help you understand that work is in cycles, and we do the repeat actions. So a cycle is a repeating movement including the return to a starting point. How many of you actually know how to clean windows with a squeegee? Right? And then how many know how to clean windows with a pole? Like, yeah? So you don't clean windows at all? And you don't clean windows at all? Okay, good. But you can relate to it, right? You've seen guys do it. So if this is my window and this is my squeegee, yeah? Then what's happened is the guy's going to come up and he's going to look after the top edge, yeah? So he might come up and come down, and then he'll come back. And then he'll get his squeegee, and then he'll come up and come down, and then he'll come back. So cycle, cycle. And then sometimes we'll come down the whole edge so that the water's off the edge, and then come down the whole edge so the water's off the edge. So that's another 2 cycles. And then he might fan, cycle, 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 right? He did the same with his mop. If I forgot to say the mop, right? So the mop, he might go across, so it's cycle, and he'll go cycle, cycle, cycle. You get it? Now with water-fed, we talk about traditionally water-fed poles. He might, you know, wet up the window, you know, cycle, long cycle, yeah, and then come back and he'll go, okay, I'm going to clean the top edge, so cycle, cycle, clean the bottom edge, cycle, cycle, right, and agitate, cycle, 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 and then he's going to take the brush off the glass and he's going to rinse it. If it's hydrophobic glass, he's going to rinse across the top edge, and he's going to have to go cycle, 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 cycle. You got it? Now, whatever trade you have as the background of your business is the same, like a pressure washer or carpet cleaning or whatever it is all the same stuff. This is what work is. So, having demonstrated to you the cycles of a window cleaner, I think that it's not unreasonable to say that 2 seconds is a generous cycle time. Yeah? So in other words, any one cycle for a window cleaner, like when he, you know, goes to cut something up, or he does a fan, like none of them are really 2 seconds long. Right? They're all less than 2 seconds. So if I said 2 seconds, I'm being conservative. So when I show you these numbers. Right, so you have a look, with a 2 second cycle, this is what work looks like. So we don't get the screaming ladies. So with a 2 second cycle, this is what work looks like for a window cleaner. A window cleaner will do 30 cycles per minute. So there's 60 seconds in a minute, 2 seconds per cycle. 60 divided by 2 is 30. 1,800 cycles per hour. 9,000 cycles in a 5-hour shift. If he only works 5 days a week, that's 45,000 cycles per week, 1.8 million cycles per year. Now, if his cycles were, just to give you an idea, if his, well, how many of you work five-hour shifts in peak season? More like 10, 11, 12, right? So we could double that to 3.6 million cycles a year. And if your cycles were 1.5 seconds instead of 2 seconds, that 3.6 million becomes 5 million cycles per year. That's what you do. That's called work, right? That's why we eat a lot when we work, isn't it? It's interesting. Now, once you identify that, how many of you have been in window cleaning management? Can you see if we can turn the heat down in here? It's a bit, almost bordering on sleepy heat. How many of you have been in window cleaning management? Anybody? Like watched a lot of people go by, a lot of window cleaners over the years. How many years?
4.
In another company before yours?
No.
Okay. So how many people have you seen come and go?
Come and go. Not a ton. Probably about 6, 7.
Okay. What would be the average life of the 6 or 7 that you've seen? How many years have they been in the business?
Probably a couple of years.
2.
My guess.
Okay, so I know a guy from when we were up in Madison, Wisconsin. There was a guy there who's been in window cleaning for 20 years. He would have seen over 1,000 window cleaners come through. His answer is, on average, 3 years. Right? Now, there are other guys who go 5 years, and there are other guys who go longer. Right? But there are tough guys, like I'll talk to my doctor friend. I'm going to talk to you about that in a minute. But I talked to my doctor friend, and
Saw the video.
Oh, you saw it? Right, interesting, right?
Yep.
So there are guys that are built that will not fail as easily or readily as other guys, right? So guys, like he talked about this muscle here, I don't even know what it's called, spinous something, right? That one, you know, if you've got no neck, that kind of muscle, those guys don't fail easily at all, right? But the guys with just flat shoulders, like this muscle here comes across and then goes around and it actually hooks, like these muscles hook from there to there in a straight line, right? So it's quite like less stressful, but this muscle comes over and then hooks in at a right angle. So if that muscle is weak or not well built or not well developed, then these guys are going to fail early, you know, from this kind of action. So that's what he's kind of talking is everybody's different. However, what I want to do is try and propose to you that the average guy working on the tools may have only somewhere between 20 million and 25 million cycles in him, right, before he's got an injury. Because there's no data collecting about guys who come and go, right? Guys just come and go. But they may have niggling shoulders, niggling wrists, you know, that may be that they've got other reasons to come and go rather than money or stigma or something else, right? Is that we do get hurt. So that's what drove me, like to say, well, if we start thinking like that, then we should be trying to use the best techniques that we can to reduce the risk of repetitive motion injury. Now, repetitive motion injury for me, when I first came across this term, I thought about typists. Like real men don't get repetitive motion injury, right? Typists do, you know, little carpal tunnel problems and stuff like that. But what happened is that I came across this guy called Dr. Douglas J. Mills from Fort Hood, Texas, and he was an occupational health director for a division of the hospital there with a number of people that are working underneath him, whose job it was to go out and examine the work practices of the 30,000 civilians working for the Army in Fort Hood to reduce the risk of repetitive motion injury claims against the Army for the way they worked. He developed a product called Reach-iT's. It's a ratchet with a 30-degree throw. So he came to China. I had Starbucks under my house, like, you know, so I lived in an apartment. He was in the building next door. We met at Starbucks, we became friends. I was helping him with his business, and then I said, well, so what's your background, whatever? And then he told me this, and I said, well, can you help me, right? Because I actually got injured from using water-fed poles, right? So then I said, it bothers me that there's no solution or that nobody's addressing it, right? So he came and spent 100 hours or more with us, and there's loads of videos between us. But I caught up with him in Dallas last week, so we made a little live video as well, right? So that's what this is all about. This is actually, most of what I'm teaching from a repetitive motion injury point of view actually came from Dr. Douglas J. Mills. So what we have is we have these, that was the end of that science lesson, right? This is biology now. Right, so we have power and control muscles. Power muscles do all the hard work and control muscles do the movement. So power muscles are the big muscles, right? And they're used to affect large effort, but in a linear direction. And they're very, very difficult to get a repetitive motion injury. So how many of you in a past life went to the gym, had a personal trainer? Any of you? No one? But do you know that we isolate the muscle to grow it? Can you remember seeing that anywhere or on a television ad or anything like that? So basically, if a guy wants to build his bicep, then they'll isolate either over a bench or something like that, or make him hold it there, and then he'll have to, pull that muscle up in a linear sense, right? And then if you isolate the bicep, it'll grow. But it's designed to work linear. So the power muscles that are our strong ones, the ones that are going to do all the work, quads, hammies, calves, triceps, biceps, deltoid, and trapezoid. Yeah. So those are your big muscles. Those are the ones you can use all day long, right? And the control muscles are the small muscles that control direction. They're not designed to be used under load. Obviously, the load of the arm or whatever. So so they're for all non-linear movement, and these are the ones that get injured, right? So the typical ones are rotator cuff. So here it is. I've isolated my bicep. Now I decide that I want to lift my arm over here, over there, up there, and around there, and then I want to use my bicep. Yeah? So that's all being done with a rotator cuff, which has 5 points of control and can move your arm through all of that motion there, all being controlled by that. But it's like an amazing muscle. But it's not designed to be under load, right? Carpal tunnel, well, who has worked with an injury or has experienced an injury? It doesn't have to be caused by your trade, just it could be sport, it could be car accident, anything like that. Who has any injuries? Does anybody have carpal tunnel? Does anybody know anybody who has carpal tunnel? You do. Did it get operated on? The person you know?
Well, it's my helper.
Right.
When he's working, he has to switch hands with the wand. He says sometimes he feels like he can't even grab it.
Right, so there you go. So that's like, and by the way, all of this applies to pressure washing. You don't have to be doing window cleaning to understand what I'm saying, right? Carpal tunnel is really amazing. Basically, you've got a set of muscles here and a set of muscles here, right? And you want to do this, yeah, with your hand. So if you didn't have carpal tunnel, the carpal tunnel is a series of holes in here. And if you imagine the brake cable on a push bike, right? It's a cable in a sheath. So you've got the muscles here, and then they basically turn into cables in a sheath in the bone, right? And then it's through there that it works. Now, if there was no carpal tunnel, then the muscle would go from there to here, and when you wanted to go like that, the muscle would contract, and you'd look really weird with fingers hanging away off the end of it, right? So it's quite amazing. Greetings.
Hi, sorry I'm late.
No, you're fine. You're fine.
Hi.
You haven't missed much at all. Because we started late.
Good.
Yeah, so it's good. So that's the thing about the carpal tunnel. So it's quite amazing. However, an injured carpal tunnel is a guy can't hold it long, right? So that's like where we're going to come to is to say, look, these repetitive motion injuries when they go, like a rotator cuff. Does anybody know anybody's had a rotator cuff tear? Has it happened to you?
Yeah,
Okay.
luckily not yet.
What happened to him?
He had surgery.
Yeah. So he's out of work,
Yeah,
right?
long time.
Happened to you or somebody
No,
else?
somebody working out in the gym.
Right. Oh, wow. He can't, he's out of the gym.
He's out.
Right? Anybody else? You did it? Does it still hurt?
It was hurting for like 6 months, healed for like a year, it still hurts.
And it still hurts.
Definitely.
It never heals. Like you can have an operation and get it fixed, but it never heals. So here's the thing, like I get goosebumps when I think about this because what's frustrating for me is that there's nobody out there telling us this, right? That these things we call repetitive motion injury, which sounds like girls' disease, right, is actually like gonna take us off the tools. It's gonna take us out of our job. And then you gotta think about what you're gonna do next, right? Now, if you own the business, that's cool. You're going scale. It's not easy, but you get forced to scale. Scale means put more people on to do the work that you can't do anymore. You know, but if you're the working person, then that means maybe you really don't know where your future is. So then it makes sense that we start educating how to use your body more ergonomically, if you've only got 20, 30, 40 million cycles in you, even if you're a machine, like 40 million cycles, how to reduce the number of cycles, how to make those cycles with less load, less force required, less distance, less force, less work, yeah? Because you guys are mature, right? Like hats off to you guys. When did you start on the tools? When you were young?
No.
Started older?
3 years ago, 4 years
Okay,
ago.
I started window cleaning when I was 45. That was not clever. Maybe 45, maybe
Yeah,
40,
me too.
40,
Actually, pretty much 46.
1996 and 54, so 44, yeah.
I was 46.
Yeah, that's not clever.
But,
I love it, right? I loved it, but I was off the
Still
tools.
do, you know?
I was off the tools in 3 years, right? I was knocked out by the lower back one. I'm going to come to that. The other one is decabanes, this one here, right? The other one is tennis elbow, which is this one here. Right, you've had that? So tennis elbow is this action, it's caused by the wrist, right? Decabanes is this action, there's a tenosynovitis, and carpal tunnel is this one, yeah? So those are your 3 actions, which if you go over and over and over and over and over and over millions and millions and millions and millions of times, at some point, there's going to be an injury groove, and then that injury groove can go, right?
I had surgery.
Huh?
I had surgery.
Right, on that one. So just one last point, like from when we're talking about, like, so just so you know, that the definition of work is scientific, it's force through distance. So that's what we're going to, is talking about force and distance, yeah? So then the force and distance are applied in a direction. So if we go back to geometry, right, we have the y-axis and the x-axis, we remember, and the z-axis is the 3rd dimension. So for example, I'll show you here, like when you're doing water-fed window cleaning, we agitate in the y-axis, we rinse in the x-axis. But when we want to put the brush against the glass and splay the bristles, that's in the z-axis. So it's important, like what I'll cover later is, when do you put the pressure on the brush and when do you not? It comes into play. So I'm kind of introducing that now, so you've got your background knowledge. Now here's the thing, so I'll run around the world and tell people how to be safer with a water-fed pole, and people say, well, how come other guys don't do that? Like Tucker's been around for 30 years, Ergonomics has been around for 20 years, Gardner's been around for 15 years, I've been around, we've started 5 years ago. And I started feeling guilty after 3 years, which was when serendipity, God, or the universe put me in touch with Doug, the doctor, for sure, And so the people say, well, why don't the other guys do it? And they say, well, there's no money in safety, right? So they don't do it. And what I worked out, well, there's also no cost in safety. There's no cost in water-fed pole safety, so I'll show you why. To increase your safety, what we need to do, now you understand the definition of work, right? So what we need to do is reduce either the force required to achieve the task and or the distance traveled in the cycle. So you've done less work. Less work means you're safer. Each cycle is less, or less cycles means you've done less work, yeah? And the definition of efficiency, if I wanted to make you more efficient so you can make more money and get more done in a day if you want to, or finish earlier if you want to, is we need to reduce the force required to effect a task and or the distance traveled in any cycle. So there's no cost. Like if I can make a worker more efficient, he is naturally and inevitably, and he inherits being more safer. So there's no cost. So if I can reduce your work, I can increase your safety, and I can increase your efficiency at the same time. You make more money, you go home, you get the choice, yeah? So let's have a look at this safety, the term safety. So this is a little module where we go through the body parts, so it's like another biology lesson. And then after this we go outside and go on the glass, right? So we've got a little spot where we can hook up to a spigot, and then I'll show you the brush working according to the logic, and then we'll come back upstairs and go through the theory, so you don't have to listen to me blah, 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 right, for too long, right? To get a break in the middle. So this is about understanding the body parts that can get injured and why they get injured and how we solve those problems, right? Dr. Doug and myself. What's that? So the definition of safety is the removal of risk. So here's an interactive part, right? If I was to ask you, what is the risk of you, how many of you climb ladders? Let me check that. Okay, oh, wow. So you must do roofing, is that right?
Have had.
Right, okay, have had, yes. Have climbed ladders, good. So, and there's no right answer to this because I'm actually trying to make a point. If I said to you, what's the risk of you falling off a ladder tomorrow, assuming you climb a ladder tomorrow or you were going to climb a ladder tomorrow, what would you say? What would be the answer? Yes?
Same amount of risk as it was yesterday, last week, last year, next 5 years.
Correct.
It's exactly the same every day.
Which risk is it?
Hey, risk, you didn't ask me the degree, you just asked me when it would happen.
No, I agree. I completely agree.
Yeah.
That's the right answer. But if you had to say what risk, I don't want to use that word. What risk is? How would you define the risk? So if your wife says, "What's the risk of you falling off a ladder tomorrow?"
The odds.
Yeah, the odds. Let's say.
Well, it keeps increasing because you've gone so long without it. Problem is-
Probably statistically, it's increasing. Yeah. If the odds are the same every day, then it increases every day that goes on.
No, it
by
doesn't, it
statistically.
stays the same every day.
Because
Doesn't
you
increase
increase
potentially.
Right.
Your odds are the same every day.
Every day does the
Every day
same.
you don't have an accident, doesn't mean you're that much closer to having an accident.
Okay.
It's just statistically
okay.
not correct.
Statistics, good.
10%, I don't know.
No, so most guys, the first answer usually is 50-50, right? Now, it's not 50-50 because that means you'd fall off the ladder every second day, yeah? So, but what they do is, what I respect is that's how they treat climbing a ladder. I have a 50% chance of falling off this and a 50% chance of staying on it. That means he's respecting the risk, right? So in that sense. So let me talk about it a different way, is if we said like this, if we said that a definition of risk is actually, instead of being the chance, right? Because usually the answer is chance, right? Or the odds. What's the chance of you falling off? And for some of the meetings that I've been in, we've had this, especially when I had the supervisor who's seen 1,000 window cleaners in his career, right? He was working for a big company, loads of window cleaners through. He would have seen 2 million work hours and 10 to 20 accidents, right? So the statistics of what's the chance of you falling off a ladder, you know, is somewhere between 1 in 80,000 or 1 in 1 million. But you know, it's remote. The chance is remote, yeah. But it still happens. And so if the definition is risk equals chance times consequence, then we'd say the definition of chance is the probability of it happening, which could be 1 in a million, right? But the consequence is the result of an event if, by chance, it happens. And so that's, when you look at JSAs and worksite evaluations, you know, when the government starts introducing more and more of the OSHA stuff that's just come through, you'll see that you have to evaluate the risk that you're taking when you're using a tool or climbing ladders or whatever. And what they're interested in is the risk of the consequence, right? What's the worst thing that could happen? And they're not really interested in what's the chance of it happening, right? Because dead is dead, right? So they don't want dead. So the removal of risk is the reduction of chance and the reduction of, or the reduction of consequence. So that in the water-fed pole industry, you can understand how water-fed poles started to become sort of respected initially, was not so much that they were particularly faster, but actually that they were perceived as safer under the definition of the consequences reduced, right? I've covered that earlier.
Workman's Comp Board agrees with you.
Yeah, like it's all happening here. Like if you came to Australia, or if you go to the UK as first, they're the worst. Like it's illegal to use a ladder in the UK unless there's no other way to do it. So in the UK, the law applied to a chain of, what's called a chain of responsibility. So you can't hide behind a company, you can't hide behind a contractor. So the facilities manager, the property owner, everybody's in the chain of responsibility, all the way down to the worker, right? And then the same as Australia, we've got that in there as well. But in the UK, if there is a way to do a job safer, that way is law, whether you know about that way or not. Right? So you can't plead ignorance. And then you can't hide behind, well, that's the contractor's fault, right? Because he didn't know, or the worker didn't do whatever. I mean, they can definitely push it to the worker if the worker doesn't do as they're told. But, you know, the principle is, you know, safety has become really high. So you're only just watching that happen here and now, starting to, you know, different states are at different levels, yeah, of safety. So if you look at ladders, the chance is incredibly unlikely that you'll fall off your ladder. Has anybody fallen off a ladder, by the way?
3 times I can think of that.
Okay, worst thing that happened to you?
But it's kind of sore, you know, and been knocked out in one time.
Right.
It wasn't very far, I mean, it was a short.
Oh, a
distance,
little
you
ladder,
know.
right.
Yeah.
You're a lucky dude.
And the wind blew me off where I was, I didn't fall around, I just fell on rocks.
Wow.
And boy, I hurt. But these 2 spikes out the back of the truck, I could have gotten peeled.
Yeah.
It was hauling lumber anyway. Then I was home, I just fell off my ladder on the sand, but it still, you know, knocked the wind out of it.
Yeah.
I had chainsaws up this palm tree, and then when the tree fell, it sprung the trunk back.
Oh my God.
Put me off, you know.
That definitely puts you off.
Yeah, so maybe I won't do that again.
That's right. Right. So without watching a YouTube video first, right? How to cut a palm tree. So how many of you know anybody else who's fallen off a ladder? Yeah? What happened to them?
He's still in recovery.
Right. How long
It
ago?
happened 6 months ago.
Okay.
And probably to the tune of about $20,000 worth of medical.
Well, anybody else? Okay. Ladders are bad because they have catastrophic accident. So first step from ladders is to keep the guy on the ground. That's the argument why nobody's ever looked at waterfed pole safety, because they're hiding behind this reduction in catastrophic accident. But if I can explain to you this, we don't even know what the chance of repetitive motion injury is on a worker, because as a rule workers come and go, right? So the guys that want to stay in the business, most of them carry some sort of pain. By the way, the definition of an injury is pain, discomfort, numbness, and tingling.
And it's also called getting old.
Well, getting old. Well, the question is, are we getting old, or have we got
sustained injuries?
have we
on the
done our
leg.
20 million cycles,
Sure.
right?
Yeah.
So we don't know, right? So the guys who've climbed ladders or skied for their whole lives, you know, have got bung knees. I didn't do either, and I don't have bung knees. You know, so are we old or are we worn out? Yeah. How many of you get locking fingers when you wake up? Yeah. So that's carpal tunnel, right? So it hasn't gone yet, but you're getting the early signs that you have a chronic injury on its way, right? So that's the
See, I just learned that.
yeah. So you start getting locking fingers.
Yeah, pressure washer.
Yeah. Yeah, because the pressure washer handle should be a 2-inch diameter,
Tennis
and
ball.
they give you a small one, right?
Now I do the tennis ball.
Right,
Squeeze it in.
exactly. It's insane. They're like, so there's nobody looking at this stuff, but the hand is designed, the Caucasian hand, it's an American university, said the Caucasian hand should grip around something about 2 inches diameter, right? If it's, like I can make poles cheaper by making them this thick, right? But you look at my thumb and fingers overlap, right? So that means I have to grip more. But if it's 2 inches thick, it's natural. And if it's 3 inches thick, then you're gripping with your fingertips and your thumb tip, right? So there's a natural squeeze grip that's ideal for the hand. And pressure washer guns are smaller than that, as a rule, which is it's not my business. I don't get involved in that. But
Just do the ball round.
so here's the thing, we talk about all those injuries of guys falling off ladders and stuff like that, and we look at how debilitating it is, the guy's out of action for 6 months. But when I look at, you know, what the consequence of a waterfed pole injury, and by the way, you don't have to be injured by using a waterfed pole. You may have an injury from sports. A baseball player has a rotator cuff problem by nature of being a baseball player, right? Yeah, the pitcher, yeah, and the batsman, yeah? So they're both using rotator cuff in the power. And so you could have a sports injury, motor vehicle accident, fell out of a tree when you're a kid, whatever it is, you know, then when you, whether you're pressure washing, whether you're window cleaning, whether you're water fed polling, if you feel it, like pain, discomfort, numbness, tingling, right, then that injury is being aggravated by the work cycle. So you'll see guys, like if you have to use this muscle here and you're doing this and it hurts, then the guy will come around here and do this and use this muscle here. It will take the load off the one that's uncomfortable. Yeah. But the most important thing is to identify that whilst we think that repetitive motion injury is kind of like a girl's thing to get, the bottom line is if you get a rotator cuff, you're in recovery for 6 months. If you get carpal tunnel, you can't hold a tool at all. You can't even pick up a cup of coffee. Yeah?
So that happened here when I had to get the surgery. I couldn't even hold the cup of coffee.
Yeah.
I couldn't.
Insane, right? So the load of the responsibility, I think, is high. You know, if we can, you know, sort of tell the story and say, you know, we should be careful about these injury grooves, these repetitive motions, and then try and make them as ergonomic as possible. So, to understand water-fed poles, then we need to know what it is. I'll show you this. So this is a scientific definition of a water-fed pole, and once you get this, then you can understand what the risks are, and once we know the risks, we know how to get rid of the risk. But obviously the answer is to not, I'm not going to tell you all the risks and then not give you an answer, right? So what Doug defined it as, he said it's a, first thing he said it's a tool, right? This is how you make money, right? So it's an industrial tool, and when he told me that changed the way I looked at water-fed. We don't make poles, we make tools. Now I make a tool, I got to make the tool as efficient as possible and as safe as possible. So if you have a motor vehicle and it's got airbags, you don't pay extra for the airbags, right? The manufacturer says, I have a responsibility to make sure your car is as safe as possible, you know, within this price range. So they put airbags in and ABS and all that. So the same kind of logic. So what he said is it's a linear, that's obvious, yeah? Oh, a bimanual, right? Bimanual linear overhead tool, you know? So that's what a water-fed pole is. In fact, all poles are, if you're using them, you put a squeegee on them and they're still a bimanual linear overhead tool. And that's what identifies where the risks are with them. So if we look at each body part, here's the first one. How many of you, when you look up, get a sore neck? Yep. So that's basically an injury. So especially with water-fed. Now we clean windows up to 75 feet, yeah? So the closer you are to the building, the more you've got to extend your neck, and then that's the, how many of you get tension headaches? Does anybody get those? Yep. So we see, you know, in the room, there's usually a third of the people in the room get tension headaches.
You 75 feet on the water on the pole?
Sure, no problem. It's high, but that's what we do. That's
Field glass and see what you're doing. I mean, how do you hold the pole?
no, it's maps. You
Steps
don't need
right
to
into
see.
that.
You don't need to see
Oh,
that.
no.
This is the answer.
He's got two of these glasses working.
So you got a little camera up on the end of the.
No, you don't need that either, because it's just maths. You're only mapping the window. You don't need to see what the result is because you know the result is right. Right? We know how to clean a window.
You could do it in the dark then.
You could do it in the dark if you can see the window. You need to see the window so you know how to map it, right? So the answer is these. These are called prisms, right? So they're basically using prisms, and then when you put them on, you know, I'm looking here, but you know, I can see my hand, right? So the logic is, huh? Yeah. So that's my point. Is when you get airbags in your car, that's because the manufacturer recognizes that keeps you safer. And if you buy a Reach-it pole, I recognize that these keep you safer, so you get them for free, included in the system. So just so you get to experience them, we tend to pass these around. I'll start here. So you put those on, and then I'll pass you the pole. I'm going to extend it a little bit. All right, so here's the pole.
Not the driving glasses?
Not good driving glasses. All right, so then you can see straight up, like.
If you had a mirror, you go to golf, you can see the bus.
Yeah.
Oh, okay. Oh my God.
So what happens is you're not going to stretch your neck up like this ever again. And it could be, you could be, oops, you could be a painter. You know, there's other jobs that you do when you're cleaning that you may need to be, you know, cleaning ceilings or painting or anything, like you could consider that this is an answer.
Looking on your car.
We aren't gonna be that close.
Duct, the guys who look up ducts, or somebody was telling me the other day, I don't know, I've never done it.
Duct work.
Some of the duct work where they're, you know, sort of twisting their neck up.
Drywallers,
They
metal
can take some
workers.
getting used to. I like it.
They do.
Yeah.
Now, how many of you get motion car sick when your wife drives?
I just get sick, period. Like my wife doesn't drive.
Does anybody?
Who's sick of your wife?
Yeah.
Yeah.
I probably could.
Does anybody actually get motion sickness from the wife driving or and somebody else driving when they're in the passenger seat?
When we're young.
When you're young?
Yeah,
Right.
I mean.
There's definitely a percentage of the population that can't handle the other person driving the car.
Yeah.
And I'll tell you what it is. If that was you and you kick her out of the driver's seat and put her in the passenger seat, you get in the driver's seat, your motion sickness is gone, right? So it's actually that you're a control freak, right? You're out of control with your wife driving, so you feel nauseous, like your body is sending you all sorts of signals because your brain.
She's a really bad driver.
Yeah, assuming that in your version of the world, from that seat, you know, looking from, you know, a 6 foot displacement to the right or the left, it feels like she's a really bad driver.
Oh, yeah.
So here's the thing, that the reason I bring that up is because these glasses can cause you a sense of disorientation, a sense of nausea, and then if you get that, then you identify that that is just, you're wanting to be in control, the data is not coming in the way you're expecting it to come in, so you'll get a sense of overwhelming nausea, and it lasts for 2 or 3 days as you're getting used to the glasses, and then it goes away forever. All right, pass that poll to the next
Yeah,
one.
just checking the hardware here. It's sturdy.
Is it?
It's built well.
Real well.
Industrial.
I'm gonna take that bad boy out on the glass in a minute. So you'll never look up again. So the trapezoid, like where the tension headaches come from, the trapezoid pulls on these muscles here, shortens them, knots them, and then the knotting of them cuts the blood supply to the brain and causes the tension headache.
That's one of my buddies that's window cleaning.
All right.
Brush.
Yep. And he's getting tension headaches.
Well, he told me, I said, you need to hold the eye, you know, constantly looking out.
Right. So there's no doubt that these are good for 3 stories and up. Like 2 stories, you're kind of all right. And you remember the further back you get, the less you have to extend your neck. But if you're in, 3 feet from the house and you've got to look up even at 2 stories, it becomes, you really notice it. It's pretty cool, right?
Yeah, that's interesting.
Get about a set of dinner plates.
Because quite often I've got millennials like loaded in the room, right? But you're the only one here, sort of like a room full of old men and you, right? And I got Seth at the back of you.
You still got plenty of cycles left.
Emotional. Can you imagine if you can take your 20 million cycles that would wipe you out in 4 years and say, okay, I know exactly how to manage, my body, and you also know to get yourself, in a position to be a team leader or, something like that, so you know to, reduce the load on your body, use your skills and your knowledge and your personality, well. So, yeah, you're gonna do really well. All right, that's prisms. So the next one is to look at shoulders. And what Doug taught me was this. He said, when you look at a boxer holds their arms like this. Obviously, they're not holding them like this. But he said, this is natural. Yeah, those guys are doing it. So he said, like, everything should work in alignment, right? The arms should swing like this. The legs should walk like this. He said, if you could climb a ladder like this, you wouldn't have bum knees, right? But you have to do a ladder like that, or like that, or like that. Whatever you do, you're going out of alignment. So then your control, all the control mechanisms around the knee are actually working under load, and that's what wears your knees out. So, so if you do this exercise with me, if you hold your arms up like that, and then instead of going like that, bring your elbows into touch. And just try that and feel the pull across the rotator cuff and the shoulders pulling in, right? And what that does, so that to the elbows touch. So if you get the elbows, yeah, so you feel that pull in. And that's what Doug said is that the human body, like the more, he's got a word for it, but the more you bring it across to the center and even across the center, then you're increasing the risk of stressing it, like taking it out. It's not really designed to work in the center. It's designed to work here, yeah? Like when you run, like girls run, like but guys run, like, you know what I mean? That's the proper way, so the ergonomics. So what we're going to try and do is get you to understand how to be more ergonomic when you're working with a pole. So Doug said the first thing, because we've got this bimanual linear overhead tool, yeah? And he said that's the problem, you're coming to center, yeah? So he said ideally, this doesn't look very right, but it's the only way to demonstrate it. He said if you were centered, ideally the way you would clean windows is like this, yeah? And he said that would be it, but that doesn't work because you have to come to the side to get any power. So he said if you couldn't do it from the center, he said you should have two handles. So this also doesn't look very right, but you'd do it like this, yeah? So you'd be working with handles, but that doesn't work either because it's not practical. You know, the pole changes lengths and all sorts of things. So he said that's the problem with water-fed poles. So he said the only other way to do it is to offset the top hand. So this is basically a control handle. So if you imagine before, I'm cleaning like this, and you look at this shoulder, this arm is coming across, you know, across in towards the center and working that rotator cuff harder, right? And then you watch what happens like now, right? So it's not perfect, and it might be better. It might be better if it's like slightly up, you know. So you'll work out, you know, how to make it comfortable for yourself, right? But it does get some offset towards that place. And the other thing that happens is that when we hit bird dung on the window, right? So if I put that there, and normally if I wanted to put pressure in the Z direction to splay the bristles to agitate the bird dung, I'm going to press down, pull on this and press on that, right? So which muscle am I using when I push down like that?
Rotator.
Yep, rotator. The shoulder, right? The top of the shoulder. Now if I had this, which muscle am I using? Huh? And the one underneath? The tricep, right? I used to have really big and beautiful triceps, so that you'd have been able to see it working. Now it's dweeby. Almost looks like an accountant. Need to get back on the tools, yeah? So you can see that by having a control handle, as we call it, you know, you've got some chance of some ergonomics. And when you're working, like if you're doing residential and you're going from one window to another window to another window, you know, then it's not so, they're in your way in a lot of ways, right? But also the number of cycles you're doing is not sort of so repetitive. But if you get onto a commercial building where you're just going to be working that building, then you'll really love it, right? Because then it's just like big movements, yeah, like that. And this arm is working much closer to its natural position rather than being, you know, pulled across. So then we go to elbows and wrist. So tennis elbow, this one's called Decker veins if it goes. It's very similar to carpal tunnel and then carpal tunnel. So what he said is what we need to do basically is isolate the wrist joints. Because he said what the problem is, we have a squeeze grip, yeah? Even though this is 2 inches round, so it's ideal, it's still a squeeze grip. So if you look at that bottom wrist, you look at the action that it's going through, and we might try and let go of that, you know, if it's not a heavy pole, but you watch in there, if I actually squeeze grip the whole time, you can see that Decker veins repetitive motion risk occurring. And it might be good for 20 million times. So you've never fallen off a ladder until you've fallen off a ladder, and I can tell you, you don't have a repetitive motion injury until you've got a repetitive motion injury. But when you do, it's as debilitating as surviving a ladder fall. And that's the point. Yeah, so it's worth being serious about. So this little baby is called the power handle. So instead of working like that, right, I can isolate the wrist and the elbow. Right, so I can run from the shoulder and I can keep that much closer to in line. You see that? So I've gone from a squeeze grip to a bucket grip, right? And then I've gone from, I don't have to use the wrist at all, I've isolated the wrist, and if I wanted to, like you see a lot of guys still, go like that, so they use the elbow. But if I wanted to isolate the elbow, I can run from the shoulder. And we had a guy who had such a chronic wrist injury, he was getting steroids and stuff like that. I don't know if you know, but when somebody's a serious bodybuilder and weightlifter, then they have these straps on their forearms, and they're stitched in. They've got a steel hook, so when they actually pick up the weights, they're not picking up the weights with their hands and their wrists. They're picking up the weight with a hook. So we modified one of those, like Doug, he modified that, and we modified this, and then the guy could get his hook and hook it onto there, right, and keep working like that. I've only done it once, and I only want to do it once, but it's kind of like proves the point. You can actually isolate out all of the injured body parts and keep the guy working, so, but you don't want to go there. But it's interesting that we can do it. That's, some of it is working out what we can do first. Yeah. So here's the thing. So some of the things that comes under this. The other one is lower back. So this is what took me out of water-fed, is this point here. Now, there goes my spine, and that point there is on the left. You know why? Because I'm left-handed. So my preference for water-fed, like I started water-fed window cleaning in 2006, when the poles were made of fiberglass, and some of them had some carbon fiber in them. I called hybrids, but not much carbon fiber. They were heavy, the diameter was big. All right, you remember those? The tuckers were the same going back 30 years, 20 years, 10 years, and even now, they're the same. So they're heavy, and so what Doug said, again, if I could have cleaned the window like that or like this, I'd be all right, but because I have to turn sideways, and then what we do is we do this off-glass rinsing, so we pull it back. So he said, what you've just done is you just completely overloaded this tiny little control muscle that's got no responsibility at all, ever, to do that. And I used to walk around everywhere. I'd even sit down at the dinner table going like this. I remember it now, And that's actually why I stopped. But I'd forgotten that that's why I stopped, and that's what makes me think that there's no data on why people stop, So the answer to that is to educate on posture and stretch. And what Doug said, because you saw the video the other day, right?
Yeah.
This was interesting. He said, go to the gym, right? Because he said, whatever muscles you're working with, you're not working the rest of them. So if you really want to, the whole body is strong. The other answer to the lower back is on glass rinsing, because if you have off glass rinsing, then you're using your core and your lower back to counterbalance the weight of the brush and the pole, for that. So if you could have on glass rinsing, then you eliminate all of that. You never have to pull the pole back.
I've seen some of the demos in the shows, and they do off glass.
Yeah, the history of on glass rinsing. The first tucker brush had on glass rinse, right? Had a spray over the top. The first Ionics brush, 10 years later, the first company in the UK had on glass rinse, right? But nobody could answer the design such that it worked, so they all went back to pencil jets in the middle. And the problem is that when you put water over the top of the brush, you wet the frame. And when you wet the frame, you introduce dirt into your rinse water, and so you leave spots. So that's what, like 5 minutes from now, we're gonna, do you want to run down and set that up?
We can do it all at once.
We can
Won't
do it,
take
it's
but a
not it's so
second.
close, isn't it? Maybe we'll just make sure we've got the right pieces.
We wanna watch you put it together.
I didn't see.
Well, no, we just got to put the hoses on because we've got a spigot that we can use. We're going to go downstairs now, get a bit of fresh air, and I'll show you how to clean windows faster. But you understand from a safety point of view, we've covered that. The next one is the demonstration. Then we'll come back and go through the theory of efficiency. So we've done safety, come back and do efficiency, and then we'll have question time. Yep. So here's just one point. If water-fed poles are safer than ladders, then are all water-fed poles safer, or is there a difference? And I'm going to suggest to you that there's a massive, massive, massive difference between a floppy pole and a rigid pole. In particular, if you come off glass and it's flexing a lot. See what it says. Basically, floppy poles require more effort and more distance. So if you've ever used a floppy pole, it's going to flex and whip, right? So you have to use more force, and then the brush goes through more distance. So we've got a video on our website from Dr. Doug where he measured me. I was doing the same window, the rinse off glass rinse, because this all happened before construct brush. We were doing the off glass rinse with a floppy pole, and then we were doing it with a rigid pole. And he only had a whiteboard marker on him, but he was basically measuring my top hand, as I'm doing the rinse action, coming down the glass. And so he said with a floppy pole, my hands were going from there to there, but with a rigid pole, only from there to there. So it's definitely just that, and that's why you need to know force through distance, because if I told you that any other way, you wouldn't get what I'm saying. The distance was half, the work was half. That's the definition of it. Right?
There's actually a YouTube video, and there's 8 different poles, and they're all extended out, and you can see them in
Right.
the various.
Some of those are deceptive.
Yeah, well,
Yes,
a
depending
lot
on
of
who made
that
it.
is deceptive.
Depending on who made it, they want to promote the one they want to sell.
Right,
So
right.
the weakness of that is, I caught a particular supplier with a Reach-it Pro.
Well, you were
at the
right up
IW.
top. You were right up
Right,
top.
we're up there. We're getting better too.
Yeah.
Like we keep every year we try and make it more rigid if we could, because carbon fiber can get cheaper,
Yeah.
and we can get, our volume of sales is bigger. But I do see some rigged ones on that as well. So by the way, if you want to test a pole, how floppy, how rigid, if you want to compare the poles that you've got, if you've got a lot of them in your business, this is called a 3-point flex. You put them up on a shelf here and a shelf there, or both on the same height, and then you put a weight in the middle, and you measure the difference of the flex. So that's a scientific, like a legitimate scientific test. There's a 3-point flex. You could put 10 pounds or 20 pounds. If you really want to see it flex, put 20 pounds, right? But we make poles like the ones that go to 7 stories, like would flex over 25 feet, would flex this much with 20 pounds on them. Yeah? And other ones will,
Go to the ground.
Other ones will go to the ground, yeah. So there's massive difference in what you're buying. And then sometimes, like we had a big room and we had a fiberglass pole, we'd play this game, right? Where you say, grab your pole and just make, at 25 feet, make 3 points, and then just try and hit those points with a brush on your pole, right? So you try and just hit it. You go 1, 3, 2, 1, 3, 2, like that. And if you can't control that and just make it happen, then you understand that that's your efficiency. Is when you're working, you haven't got that efficiency either, right? So precision and accuracy delivers a better hourly rate.
It's the same as when you're spraying, you have a long extension wand, and you can't, when you put a little pressure on things.
Oh yeah. So the efficiency, it takes time to control it, right? So rigid poles deliver more accuracy and more precision, which affects your hourly rate. Because what's happening is, remember that the pole is replacing the ladder. That its job is, to be rigid, to be an axle, So whatever you're doing on the ground, you want to happen at the brush. Now, if the pole flexes, right, then flex is loss of energy, right? So if you took a piece of wire and you wanted to break it, right? Those of us who are bushmen would know all about this, right? So you bend it and bend it and bend it, right? Now, cycle, 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 work, 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 calories, 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 right? Coming from me into the wire. What happened? What do you feel with your fingers?
Heat.
Heat. What is heat measured in? Calories, right? So you're working, right? Working, and the flex is being lost, the flex is the loss of energy, effort in heat, in calories, measured in calories. So every time you have a floppy pole, right, you accelerate, and the pole flexes way more under acceleration than it does under continued movement. That's why the force is there, right? So the more you accelerate, the more you want to work faster. Like if you have tried a floppy pole and you really try and work fast, it becomes more impossible. So you have to slow down, right? So you accelerate. But every time that pole flexes, that's your calories that you paid for when you ate, right, being lost through that pole in calories. It will be getting hot, but you can't measure the heat. You know, if you had this micro, right, measurement thing, you would see it, but because the surface area is too big, you know. But that's what's actually happening. So what you want to do is what I do on the ground here happens up there if you're working at heights. Yeah. So rigid axle. We have a website with a load of videos from Dr. Doug explaining all of these. Like we had a guy working for me who was a marathon runner, so he kind of, you know, Doug had him take his shirt off and then go through and mark his body for the different points, you know, so you can see the trapezoid. You know, he'll write on it with a pen and the tennis elbow. So you just went through in the lower back and showed where the wrist points are. So there's some really cool videos there as far as educating teams and stuff like that. Just because this is about safety, remember that electricity can jump. Yeah, it doesn't. You don't have to touch a power line to be killed by a power line. So it can jump up to 10 feet in most conditions, but 500,000 volts in a humid environment will jump up to 20 feet. So Dr. Mills was doing his degree at the university, and one day he's walking across the sports field, and there were power lines. I don't know why there isn't near a sports field, but anyway, maybe it wasn't a sports field, but anyway, it was at university. And a guy was carrying an aluminum ladder, like I don't know how big it was, but you know, he was carrying it straight up, and then the power line arced across to it. His buddy came across to try and save him, and he watched them burn to their knees. One of them died on the spot, and the other one died 2 days later.
Okay. Don't touch them.
Go on skis, don't touch them. Yeah. So that, you know, if you understand that electricity is like quite chronic, a problem, and that's what we have is what, you know, is JSA or site assessments, you know, being able to get in and look up as part of your site assessment before you start working and make some decisions, just in case you end up fatigued and you stop being so conscious. Make your decisions before you start work, when to be careful, trees and power lines and stuff like that. And we had a guy in Denmark, he touched power lines, exploded his Reach-it pole in 2 places. Fortunately, like we have the handles on here for demonstration, but normally you'll get your Reach-it in a neoprene sleeve. This is called a pole skin. So normally if you're just using it like residentially, you'll use this. And this, that guy exploded the pole, but when he got another pole and kept working, he didn't feel anything. He had sealskin gloves on and he had neoprene pole skin on. Now basically anything that insulates heat also insulates electricity, unless it's wet, right? Because the electricity can travel through water, right? So, you know, just like we try and address the issues that you face, we can't stop you from hitting a power line. So you insulate handle and hands. Warning number 2, just high wind. Those of you who do want to go to 4 and 5, well 4 stories is still okay actually, but 5, 6 and 7 stories, wind is a little enemy. Sometimes you'll have wind coming over the top of a 4-story building and hitting your pole at 5 stories, and you're not feeling any wind at all. So, you know, there's a whole lot of strategies, you know, how to manage a pole at heights in wind. But the most important strategy is that if you don't feel safe, don't do it, you know, because wind, you know, basically the risk of a pole falling is the length of the pole and whether there's somebody else there at that, you know, time, right? So if you've got a 70-foot pole then the risk is 70 feet away, yeah, whether somebody could be there or not. So it's, it gets worse if you get glass-clad buildings without frames on the windows, and then you've got to cling to the edge of that. So this goes back, the industry, especially if you're a gardener fan, the industry has got tiny little brushes, right? So they're usually 10-inch brushes is the standard gardener brush. And we also followed them when we started in the industry making our own brushes. We made small brushes. And then I worked it out that, you know, because the industry was full of floppy poles, then the way to make a pole less floppy is to put less weight on top of it. So if I can make a lighter brush with less bristles, smaller, make you work with that, then you won't feel how floppy it is. But you start putting a 16-inch brush or a big brush on that pole, you know, then it becomes even harder to control, impossible. So you can't use a big brush on a floppy pole. So, so that's, you know, another benefit of having a rigid pole, as you'll see what I show you downstairs, is that a rigid pole can handle a bigger brush, and a bigger brush is no different than a bigger surface cleaner or a bigger ride-on lawnmower. It's going to cover more territory with each action, which ultimately means that you'll have less distance traveled to achieve the same result. Yeah. That's it. Let's go outside. What do I need? This.
Someone does a brush.
You collecting these?
Yeah.
Yeah.
Get them at the end.
I thought.
Is that one of the heavy ones?
Yeah.